are you doing? All good? All are safe, all are healthy, all are fit? Great. I'm your Mahesh, your physics teacher, and you're watching SMR Online Physics, my YouTube channel. Right? Are you excited about today's class? Then give me a thumbs up, right? Good. Let's get started. This topic will be, yeah, you can guess it. We'll talk about how spherical mirrors form images. How they form images, just like a plane mirror forms images, spherical mirrors, both concave as well as convex mirrors can form images. They can form real images, they can form virtual images, and what are the basic necessities to understand the formation of images by both the mirrors. Here we go. Today we'll talk about the image formation by spherical mirrors. Image formation by spherical mirrors. All good? Ready for it? Yes. So before learning about the image formation by spherical mirrors, that is concave mirrors as well as convex mirrors, first of all, every one of us should know what are those principal rays with which we can construct a geometrical diagram to study the formation of images by spherical mirrors. So let me first of all make it very clear what are those principal rays valid for both concave as well as convex mirrors. They are called principal rays. In totality, for concave mirror we have 4 principal rays. For convex mirrors we have 4 principal rays. Is that clear? Right. Let me show you the principal ray number 1. First of all, learn to draw your concave mirror correctly. Draw an arc. Put these oblique lines. Then draw your principal axis. Mark the point pole. Mark the point focus. Mark the point center of curvature. Make it sure that the distance between the pole and the focus and the distance between the center of curvature and the focus looks approximately equal, because it is mathematically proved that for spherical mirrors with small apertures, the focal length is approximately half the radius of curvature. So here we go. The first major principal ray which is needed to construct a ray diagram says, if a ray of light is incident on a concave mirror parallel to the principal axis, then after reflection, the reflected ray passes right through the focus. You can see that the concave mirrors, as we discussed already, have a reflecting surface which is curved inwards, the inner curve of a spoon. I'm sure you all remember that, right? So this is your first principal ray. Any ray of light incident parallel to the principal axis after reflection always passes through the focus. So in this case, if I ask you which one is the angle of incidence and angle of reflection, just be cool and draw your normal right from the center of curvature, passing right through the point of incident. Very simple. This always makes an angle of 90 degrees with the surface. Hence, as you already know, the angle between the incident ray and the normal is called angle of incidence. The angle between the normal and the reflected ray is called angle of reflection. So by the laws of reflection, angle of incidence is equal to angle of reflection. As simple as that. Got it right? Okay, let me show you the second principal ray valid for concave mirrors. Draw your concave mirror, put in these oblique lines indicating the non-polished surface of the mirror. Draw your principal axis, mark your point pole, the focus, the center of curvature. The second principal ray valid for concave mirror says that, which is exactly opposite to the first one, in case a ray of light is incident through the focus of the mirror and strikes the mirror, then after reflection, can you guess it? In which way it's going to get reflected? If you just follow this diagram, yes, you got it right. It's going to get reflected parallel to the principal axis. Exactly opposite to each other. I will quickly tell you why it is so easy to guess and why many of you got it so correct. If a ray of light came parallel to the principal axis, after reflection passes through the focus, if a ray of light is incident through the focus, reflects parallel to the principal axis in accordance with what we call as principle of reversibility of light. Get it here, very clear. The path maintained by the ray of light in going from point A to point B along a certain direction remains to be the same. It retraces its own path. So in this case, now if I have to draw the normal, it will be from the center of curvature, again passing right through the point of incidence. So my dear students, it's very easy to see the angle created between the incident ray now and the normal. This has to be your angle of incidence, and the angle created between the normal and the reflected ray, this has to be your angle of reflection. And by the laws of reflection for mirrors, angle of incidence should be equal to angle of reflection. Got it right? Let me show you the third principal ray valid for concave mirrors. The third principal ray, first of all, you can draw your concave mirror. By this time, everyone should be sure how to draw a concave mirror on paper. This is your principal axis. Mark your points P, F, C. Never miss the sequence. Never miss the sequence. It's very popular, just like your favorite KFC. In place of K, just replace PFC, pole, focus, and center of curvature. Right? The third principal ray says that in case a ray of light is incident along the center of curvature and strikes upon the mirror. Please mind the point, in case a ray of light is incident along the center of curvature and is incident on the concave mirror, yes, can you get me right here? In which way it's going to get reflected? Absolutely, I suppose most of you got it right. This is a case of normal incidence. Whenever a ray of light is incident along the normal, it always retraces its own path. It always retraces its own path, and hence in this case, angle of incidence or angle of reflection both have to be equal to 0 degrees, because the normal and the incident or the reflected rays are exactly parallel to each other. So the angle formed will be 0 degrees, not 90 degrees, as some students make a mistake about it. Clear? And the fourth and the final principal ray valid for concave mirrors is, draw a concave mirror, get your principal axis right, yes. And the fourth principal ray says that if a ray of light incident on the pole of the mirror, if a ray of light is incident on the pole of the mirror, after reflection it reflects very symmetrical to the principal axis, making equal angles with the principal axis. So my dear students, I suppose you should be able to find out where is the normal in this diagram. Absolutely. Because any line passing right through the center of curvature and passing right through the point of incidence in this case has to be the normal. So in the fourth principal ray, the principal axis itself behaves like the normal. So the angle of incidence is the angle between the incident ray and the normal. So this is your angle of incidence, and the angle between the reflected ray and the normal has to be angle of reflection. In this case also you'll find angle I has to be equal to angle of R. I suppose we got all the four principal rays absolutely clear. Now, dear students, we'll learn how to construct ray diagrams, which many students in my teaching experience of more than 15 years, where I've taught more than thousands of students, I find that the students struggle a bit in constructing the ray diagrams. I'll teach you in the most crispiest way how to never get it wrong. Alright? So let us see how concave mirrors form images, and the construction with the help of principal rays, what we have just seen, that construction is called as forming a ray diagram. Okay? The image formation, which we are going to do geometrically with the help of principal rays, are called as ray diagrams. Alright? So let us talk about the first position of the object. Position of the object means where is the object going to stand or be placed in front of a concave mirror. Alright. So before I write down the position, let me draw a huge concave mirror. This is how it should look like. The face of the reflecting surface intentionally placed towards the left side. You will know why it is important to be facing towards the left side, which is not exactly compulsory, but it's important to be placing towards the left side. Okay? Now, draw your principal axis passing right through the mid of the mirror. Mark your point. The midpoint is the pole. You can mark your point, the center of curvature. Look at this approximate distance and judge by yourself. The approximate midpoint should be the pole of the mirror. Is it clear? Okay. Now, in case of concave mirrors, which is a very tricky mirror in the sense that it can form various types of images. It can form real as well as virtual image. It can form inverted and erect images. It can also form varied sizes of images, right from starting with a point-sized image to the highly magnified image. It can form the same single mirror. Okay? I'm very sure you remember this is your focal length, and this is what we call as the radius of curvature. So what I want to tell you, the very important beautiful trick is, we'll start with the farthest position possible. The farthest position possible, this upside arrow mark will always represent our object. This is our object AB, the head of the object, and this is the foot of the object. Is that clear? Now it's extremely far away, just like the sun far away from this earth. Yeah, such kind of a distance with respect to the size of the mirror, we can call the position of the object is at infinity. It is almost like an infinite distance away from the mirror. In such cases, the light rays coming from the object are assumed to be parallel to the principal axis. So in this case, we are going to use the principal ray number 1, which I just showed you. You can use it twice, you can use it thrice, the same ray above the principal axis or 2 below the principal axis. And by the rule of principal rays, yes, the reflected ray should be definitely passing right through the focus. The reflected ray should be definitely passing right through the focus. The reflected ray again passes through the focus and focus. This is what the principal ray number 1 taught us. After reflection, the reflected ray definitely happens to pass by itself through a very common point which can be found lying on the principal axis. That common point is also called as the focus of the concave mirror. In this case, the light rays actually travel from a very far away object. In this case, AB is the object, and the light rays have traveled and been incident on the concave mirror. After reflection, happen to converge by themselves at one common point. This meeting point of all the entire reflected beam is the position of the image of this object. And this image relatively is going to be extremely small in comparison to the size of the object. So hence we can write the position of the image. How to write the position of the image? Where it is formed like? Yes, it is formed at the focus of the mirror. In short, we could have said at the capital F position, right? Then we would look for size of the image. Always remember, my students, this size refers to the relative size of the image with respect to the size of the object. So with respect to this mighty object, this is a very tiny dot. So I could have easily said the size of the image is point sized. You could have said it as like point size, or you could have said it as like highly diminished image in comparison to the size of the object. And the third one we would love to note down is the very important one. Is the image obtainable on a screen? I mean to say, is the image a real image or is the image virtual? What's your guess? By looking at the diagram also, if you've understood the concepts properly, you can definitely say what type of image is this. Got it. The answer is, since the reflected beam is actually meeting by itself at one common point, the image has to be a real image. This is real, and here we can't notice it very clearly, but we can just note it down. The image is also inverted. The image is going to be upside down. Let me discuss about the position number 2 for concave mirrors. All right. Now, first of all, draw a concave mirror. Draw your principal axis. Draw the focus. And mark your center of curvature. I think now it's very familiar to all of you. I need not show it once again. Position of the object, where we are going to place the object. Just I said that now I'm going to bring the object closer to the mirror. The second position which we generally study is something like the object has shifted from infinity towards the mirror, slightly closer towards the mirror, but not really close. And we'll say this is like an object standing whose name is AB, just beyond C. Please note it down. This is beyond C, beyond the center of curvature. Beyond the center of curvature, in short, it is also studied as beyond C. Clear? I mean just outside of the C. Now, out of the 4 principal rays we have learned so far, I can use any 2 to construct the ray diagram. In reality, if you do it on experimental wise, we will see that as the object has come closer towards the mirror in comparison to the first position, the image which was formed at the focus will start shifting away from the mirror. Got it, my dear students? That is the trick. That is a very easy way to remember, never to get it wrong. As you come closer, image shifts away from the mirror. Alright? So I just show you, I use the principal ray number 1, which says that a ray of light emitted from the tip of the object parallel to the principal axis just passes right through the focus. In this case, you should know definitely the answer. The answer is going to lie between C and F. Answer means the position of the image. Where is the image of this object going to be seen like? So I can use any principal ray. Let me try the 4th principal ray, which says that a ray of light incident at the pole of the mirror should be reflecting in such a way that it makes equal angles with the principal axis. That's it. That's it. So these are the angles I was talking about. This is your I, this is your R. They have to be equal. And you can clearly see that in doing so, by choosing at least 2 principal rays out of the millions possible, we find that these 2 reflected rays do intersect by themselves at one common point. This common point of intersection is called the position of the image. So you can clearly see that I have drawn an arrow which is upside down, and the simplest reason is this tip of intersection is found to be below the principal axis, but actually the light rays which intersected here started their journey right from A, which was above the principal axis. So it means that the image in fact is going to be upside down, or a single word is enough, inverted image. So if this is the tip, then it should be written as A dash. A dash is the image of A, and this has to be the foot. That is how we generalize the things. If this was B, then it has to be B dash, the image of B. So you can see that relatively the size of the image is smaller than the size of the object. So we can quickly write it down. The position of the image is found to be between C and F. Between C and F. That is between the center of curvature and the focus. The size of the image relatively still is a smaller one. The relative size is smaller one in comparison to the size of the object, and nature of the image, definitely I think now most of the students, those who are following me very closely, knows the answer. It has to be a real image and upside down, that is inverted image. It's a real and inverted image. Let's study the position of the object for the third case. Alright, so far we have seen for infinity and beyond the center of curvature. Right, now as the object is going to come closer, can you guess which position is very important to be studied? Yes, if you're right, that's good. Now we'll place the object at the center of curvature. Please pay a lot of attention. Now I'm going to place at a very special point of the mirror that is called the center of curvature C. Alright, what happens if the object stands at the center of curvature of the mirror? Here you'll find we can use any principal ray, as I said already. So let me show you some different principal rays out of the 4. Minimum, remember, minimum we need to use any 2 out of the 4 to complete a ray diagram. Okay, so let me use the 4th principal ray, which says that a ray of light incident at the pole of the mirror bounces back in such a way that it makes equal angles with the principal axis, which in fact acts as a normal in this case. Okay, right. Now what do you think, where should be the image forming in this case? If you remember the trick what I've told you, you should be able to get a good guess where should the image be formed. If the object is coming closer, once more I remind you, if the object is coming closer to the mirror, the image will start shifting away. The first position of the image was focus, second was between C and F. Now the third position, when the object is standing itself at the center of curvature, the image is going to be formed exactly at C. As you can see that I'm drawing it beforehand. This is one of the tricks of drawing the diagram, always to get it right. Otherwise your pencil and scale diagram will make you falter. So it has to be like a same sized image forming at exactly the same position but upside down. I can use any principal ray I wish. So let me just show you a principal ray which is suppose passing right through the focus of the mirror. So definitely by rule, this ray has to go parallel to the principal axis, and make it sure in your ray diagram you make the ray to intersect at one common point, which has to be like almost below the principal axis. Am I clear? I've used principal ray number 2 and 4 to construct this ray diagram, which is practically very valid position, which can be practically proved. That when the object is standing at C, the image forms exactly at the C. So the position of the object was at the capital C. C is standing for center of curvature. Position of the image also is exactly the same. We write it is at C. Size of the image, my dear students, very important position. I told you this is the only position for concave mirror where the size of the object and the size of the image is going to be exactly the same. Okay, so you're going to get a same sized image. same sized image in this case, and the nature, I need not tell you again, I think you must be roaring from your homes that nature has to be real because of the actual intersection of the reflected rays of light, but at the same time this image is found to be inverted, or you want to say upside down. In both the cases you're absolutely correct. I hope you're getting me crystal clear. Are you feeling good? Are you feeling easy? Then give a thumbs up for sure. Let's look into the fourth position of the object for concave mirrors. Alright. Now I think most of you are in good shape now to get these diagrams by itself. As we're moving closer, now the fourth position is called like standing between the center of curvature C and the principal focus F. So in short, we can write it as the object being placed anywhere between C and F. So let us choose this position. This is like A, this is like your B, as we have continued with those two alphabets as the name of the object. Head is A, the foot is B. Now, can you guess where should the image form? Even if we do this experiment practically, where should the image form according to you? The images, if you go back to the first three diagrams, you'll find they have shifted from the focus, then between center of curvature and the focus, then the third one was formed at the center of curvature. Now, yes, you are correct. You are smart kid. The image is going to be beyond the center of curvature. I think you can even pause this video and try by yourself how to construct a ray diagram using any two principal rays, whichever you find comfortable to draw. So let me use the principal ray 1, which is always comfortable. A ray of light incident parallel to the principal axis after reflection by the rule should be reflecting through a point called as the focus. That's it. So one very important advice which I forgot to tell you somewhere in the early session, that do use your scale and pencil only to practice these ray diagrams, okay? Not to do it with pen like. Okay, now the image is going to form beyond C, so the formality of the diagram says, let me use the fourth principal ray striking at the pole, and now it reflects back making equal angles. Make it sure that your intersection just happens. Point is obtained here, so just mark the position where the intersection happens, and that becomes the size of position of the image. All right, so please try to draw it in much better shape. In comparison to the size of the object, the size of the image is relatively bigger in size. Is that all clear? Okay, that's good. So we'll see that the position of the image is definitely beyond the center of curvature. Is that correct? Size of the image is relatively, now we write for the first time, magnified. The image should look magnified in your ray diagram. In reality, it is a magnified image. Just take care of the diagram. I have used these two principal rays to construct it, and the nature of the image, without any doubt, still is obtainable on the screen. So it is real but upside down. So it's a real and inverted image. Let's learn how to draw the fifth position of the object. The fifth position of the object, as I used to say very familiarly, we'll learn it and keep it in our head as the fifth position, but in fact the naming of the position of the object will be, now I'm going to stand at somewhere really closer to the mirror. A very special point for a spherical mirror that is called as the focus of the mirror. So let us not forget to name the object. It is AB as usual. So now the object is standing very close to the mirror, that is at the point called the focus. So it's almost, the object distance in this case is exactly equal to the focal length of the spherical mirror. Absolutely. So now I suppose you must be roaring as I say it. You know the answers pretty well. Where should the image be formed? If we go back to the first position of the object, when the object was at infinity, the image was at the focus. Now the object itself is at the focus. So the image goes to infinity. How we show that in a diagram? Let me just show it to you using simple principal rays. Out of the 4, we should use any 2. So I'm using a ray of light which is incident from the object onto the pole of the mirror, creating a certain angle of incidence and making equal angles of reflection. It just bounces off. It just bounces off into a specific direction, obeying the laws of reflection. Is that clear? Now, I haven't used one ray, and in this diagram it looks like very comfortable to be used, so I don't want to miss that chance of using that ray. Yes, you got it right. The principal ray number 3. So let me try to use it like a ray of light which is in the direction of the center of curvature of the mirror, strikes onto the mirror. A ray of light which is directed towards the center of curvature, we all know that, yes, it will always retrace its own path. So if you observe this diagram closely and practically if you start thinking about it, then you'll find that the rays of light after getting reflected from the mirror, you could have used even the other 2 principal rays. I mean to say, the first one is also possible to be shown over here. The second one won't be possible because the object is standing at the focus, and you see that even I'm using the 3rd principal ray, you can easily see that the principal rays do not look like intersecting within the dimensions of my board, or may not be even possible within the dimensions of your page. The image is definitely going to form somewhere very far, and the image is definitely going to be real at the same time upside down. So no doubts on that. But the size of the image, as you can see here, we can safely write, is going to be highly enlarged, or you can say is going to be highly magnified, much larger in size than the size of the object standing on the focus. So the position of the image in this case, we say the image is going to form at an infinite distance. The image is going to form at infinity. Is that clear? Quickly see how to draw the 6th position of object in case of concave mirrors. All right. And the good news is this is the last position, because as you can easily see that we have already reached to the focus point. Now if I try to really get closer, I can be at the best as close as till the pole. So somewhere between the pole and the focus, the object can lie. So this position is called standing between the pole P and the focus F. Standing between P and F. This is very famously, we call it as standing like between position at the position 6. Okay. So the object is now standing here, somewhere here. The object is standing between pole and the focus. Now, can you make a good guess quickly? Yeah. Where can the image be formed in this case? All the distances possible on the left side have been completely occupied. The 5th position says the image forms exactly at infinity. Now you'll see we're using the same principal rays. If a ray of light is incident, for example, parallel to the principal axis, by the rule, the reflected ray passes right through the focus. Correct? And since the object is too close now, if a ray of light is striking at the pole of the mirror, by the laws of reflection, it's going to bounce off in such a way that it makes equal angles. You may just feel like they're going to meet somewhere in the future, but in reality it says that the image never forms by the intersection of the reflected beam of light. Rather, the image is actually formed by a non-actual intersection of the reflected beam. It means geometrically, to draw it on paper, I need to produce this reflected ray straight backwards. Because in reality, definitely for this object, let it be your own face kept very close to a concave mirror. Will you see your image in the mirror? Absolutely yes. Your image is formed, but that image is not formed by the actual intersection of the reflected beam. It is the non-actual intersection of the reflected beam which forms that image in the mirror, and hence this meeting point seems to be meeting above the principal axis for the first time for a concave mirror. So since it is above, I can't draw an inverted arrow, rather I draw an arrow point which is upright. So if this was the tip A, then this tip is the image A dash. Is that clear? If the foot is B, then this is your B dash. So hence A dash, B dash will be the image for the object AB. So here you can see that this non-actual intersection, already we saw it in case of plane mirrors, is the formation of a virtual image, an image which can never be obtained on a screen. So here I will write the position of the image to be seems like forming behind the mirror. It seems like forming behind the mirror. Yes, it looks like that. It gives you an illusion just like a plane mirror. Size of the image is definitely magnified. My dear students, please focus on these characteristics of the image. The size is definitely going to be enlarged, bigger than the size of the object. But the nature for the first time for a concave mirror is not real, but it is a virtual and upright image, which we better call it as erect image. Virtual and erect image of the object is formed. This is why a concave mirror is also used as a shaving mirror. As you bring your face very closer to the mirror, your face will be magnified at the same time erect. So giving you a very closer view of the object. Okay? I hope all of you got it right. These are the 6 positions we can study for concave mirrors. Please note it down.